Hi class, this is Neil, and this is lesson 4 on the unit circle. In today's lesson, we're going to be applying our knowledge of reference angles to extend the use of trigonometry functions for all values of theta. So all different types of angle measurements, we're going to be able to use our trig ratios for at the end of this lesson. So let's take a look first at the do now. So in the do now, we're asked to sketch and label each angle theta in standard position, and then draw the reference angle R. Finally, we're asked to sketch the reference triangle and label all possible sides. All right, so let's go ahead and get started. So for problem A, we're given a theta measurement of 280 degrees. I won't do this for all the problems, but for the first one, we can get started just by drawing in our quadrantal angles, or our kind of guide angles. All right, 280 degrees is somewhere between 270 and 360. If I start the initial side of my angle here, and I continue around to 280 degrees, again, it's between 270 and 360, somewhere about there. Sketching in theta would be a rotation all the way around the circle. All right, so that's my angle theta. And now I need to draw in my reference angle. The reference angle is the angle formed, the acute angle formed between the terminal side and the x-axis. So that's my reference angle, R. The reference triangle will be the triangle formed where that angle intersects the circle and the x-axis. So that's my reference triangle. All right, so to find my reference angle, to go the rest of the way around the circle from 280, I would really just need to travel an additional 80 degrees. If you wanted to calculate that mathematically, that would be 360 minus 280, which gives me 60. All right, for part B, sketch theta equaling 52. All right, well, 52 is between 0 and 90. It's about a little more than halfway between 0 and 90. So here's the initial side of my angle. Oh, let's erase that. Here's the initial side of my angle. Terminal side would be somewhere around here. So theta is the angular measurement between that initial side and terminal side. My reference angle in this problem is the same as theta. All right, and then my reference triangle is the triangle drawn in red here. So my reference angle here and theta are the same, so 52 degrees. All right, C. So theta is 133. That's somewhere between 90 and 180. All right, so it's about halfway between. Here's the initial side of my angle, the terminal side. All right, so theta extends from the initial side to the terminal side. My reference angle is the acute angle formed here. And now my reference triangle is this measurement. To calculate my reference angle here, again, I would need to travel an additional 57 degrees to get to 180. To calculate that mathematically, just 180 minus 133, which is 47 degrees. All right, part D. Theta in standard position and its terminal side hit the circle at K being -12 and -5. Okay, so we're given some information on this circle. I'm told that I have this point on the circle, 0, 13. There's the point K. We need to eventually find the circle's radius. Let's draw in our angle first. So here's the initial side. There's the terminal side of the angle. If I extend that all the way around, that's theta. If we wanted to draw in our reference angle, that's this acute angle formed here. And our reference triangle extends from that point K to the x-axis. All right, so we don't know anything about our angle here. We are just asked, though, to write in what we know about the sides of the triangle. Now, the circle's radius is given by this point here, because the radius extends from the center of the circle all the way to the edge. So that's 13 units. Now that radius is the same no matter where we go in our circle. So that radius of 13 is also right here, from point K to the center. So that distance is 13. Now my x value here is going to tell me about the base of my triangle. So that's really negative 12. And now my y value here shows me that vertical distance. So that's negative 5. All right, you can pause and take those notes. All right, for part E. Theta is in standard position, and its terminal side intersects the circle at A being negative 16 and 12. So that gives me an x value and a y value. Okay, so our angle goes from the initial side to the terminal side. Okay, that's going to be my theta. Now, where do we see information about the radius? All right, you're right. It's that x value here, because that's the distance from the center of the circle to the edge. So my radius of 20, I can indicate here. My reference angle is this acute angle formed here. And my reference triangle is what is formed when I drop a vertical line straight down to the x-axis to make a right angle. So there's my reference triangle. We know the hypotenuse is 20. This x value here, negative 16, that tells me the base of my triangle, negative 16. And this y value here tells me the height of my triangle is 12. Is this a unit circle? Well, the answer to that is no. A unit circle has to have a radius of 1. All right, part F. Theta is in standard position, and its terminal side hits the circle at B being negative 0.6, B negative 0.6, negative 0.8. So that's an x value and a y value there. All right, so let's sketch out what we know. So negative 0.6 and negative 0.8, if we think about how quadrants work, it's a negative x and a negative y. So that tells me I'm going to be somewhere in quadrant 3. Now, it doesn't really matter where exactly I put that point. This is just a sketch. So here's my initial side of my angle. There's my terminal side. All right, so if I were to sketch theta, it would look something like that. Our reference angle is the angle formed here, right? And our reference triangle, which I'll draw in blue, is this triangle formed here. Okay, so let's see what we know. Well, we know an x value, which is going to tell me something about the base of that triangle. So that's negative 0.6. And we have that y value. It's going to tell me something about the height of that triangle, and that's negative 0.8. Okay, so we don't know anything about that hypotenuse or the radius of our circle, but we can use the information we have to find it by just looking at the Pythagorean theorem. So if I had negative 0.8, I square it, and I add negative 0.6 and square that, I'm going to get my radius squared. So that would be 0.64 plus 0.36 equals r squared. So 1 is equal to r squared, therefore r equals 1. So this distance here is 1. So this is a unit circle because we have a radius of 1. All right, question 2 in the do now. A circle centered at the origin has a radius of 73 units. The terminal side of an angle theta intercepts the circle in quadrant 4 at point P. The x-coordinate of P is 48, and we need to determine the values of sine of theta, cosine of theta, and tangent of theta. Okay, so let's sketch some information into this circle. Okay, first of all, I know the radius is 73 units. So I could indicate that any number of ways. I might just show it here that this is 73. I could also show that this point here is 73, 0. So that's my radius. I kind of like that a little better because it keeps our circle a little cleaner. Okay, so we know that this is this point P in quadrant 4. Right, so quadrants, that's 1, 2, 3, and 4. So point P is somewhere here. And now we know the x value of P is 48. We don't know the y value. Now, one thing we do know is y is going to be a negative number. And the reason we know that is because it's below the x-axis. All right, so let's use some of this information to sketch theta, to sketch our triangle, and to solve this problem. I'm going to erase kind of our quadrants here, just so we have a little more space to work in. All right, so first let's sketch theta. Initial side, terminal side. Theta comes all the way around. All right, so my reference triangle. There's my reference angle. My reference triangle is here. Sketch it in purple. Okay, so I know some information about this triangle. I know that the radius is 73. And the hypotenuse of that triangle is the same as the radius. So I'm going to write 73 there. I also know my x value is 48. All right, so the 48 is the same as the base of that triangle. Now we need to find out what y is. We don't know what y is. All right, so let's use what we know about right triangles. We can use the Pythagorean theorem to help us find the value of y. Our hypotenuse is 73. All right, and it doesn't matter what I use as a and b. Let's go ahead and use 48 as our a value. B is going to be our variable, y, what we don't know. All right, so simplifying that then, I would have 73 squared, which is 5,329. 48 squared, which is 2,304, plus y squared. All right, subtract this from both sides. We would get y squared equals 3,025. Square root that, and we will have y equals 55. Now, important note, because we're in quadrant 4, y is negative. All right, so really our y value here is negative 55. All right, and I'm going to erase the y I have on this triangle, and I'll write negative 55 there. All right, I'm going to go ahead and just redraw that triangle just so we have a clean triangle to work with. 73, negative 55, and 48. Those are the sides of my triangle. There's my reference angle. This is my opposite side. This is my hypotenuse. This is my adjacent side. So finally we're ready to get to the last part of the problem. Find the values of sine, cosine, and tangent. Draw a little line there. So again, we would use SO, CA, TOA. All right, so sine of theta would be opposite over hypotenuse, or negative 55 over 73. Cosine of theta is going to be adjacent over hypotenuse, or 48 over 73. And finally, tangent of theta, opposite over adjacent, would be negative 55 over 48. All right, that's the end of the do now. So I know it was a lengthy one. You could pause the video, take some notes, and I'll see you in the next video.